Hello everyone, welcome back to my channel. Now this question belongs to the organic chemistry, and in order to solve it we should know about the topic of structural isomerism. So if you know the structural isomerism, this question will be a cakewalk for you. Otherwise you will have to understand the topic first and then come back to this question. Also it requires a bit idea about the optical isomerism. So how do we proceed with it? Let's see. Now the question is saying that we are having a molecule C4H10O. The molecule available to us is C4H10O. This is the molecular formula of organic compound. And in the list 1, we are giving some values. And in the list 2, we are given the different statements and we have to match them. So it is basically a match the column question. Whenever the question comes with the molecular formula of an organic compound, the first thing you should do is to find the degree of unsaturation. The first thing you should do is to find the degree of unsaturation of the organic compound. Now here we know whenever the oxygen is present in the organic compound, oxygen atom doesn't contribute towards the degree of unsaturation. We can say that oxygen atom does not contribute in degree of unsaturation. So if the oxygen atom is present in the molecule, we just have to ignore it, right? We have to totally ignore it. Now we are having C4H10. So how do we calculate the degree of unsaturation? Whenever the organic compound is given, check the number of carbons in it. Now here we are having 4 carbons, so C4. So if it 4 carbon atoms are there, then what will be the formula of alkane having 4 carbon atoms? It should be C4H10, right? So if we compare here the number of hydrogen atoms, the number of hydrogen atoms in this alkane, that is butane, C4H10 and C4H10O, are same. That means delta H, right? Change in the number of hydrogens is what? 0. If delta H is 0, implies degree of unsaturation is 0. So whenever the compound is given, right now the compound is having oxygen. Whenever the organic compound is given to us, and if it contains oxygen, simply compare the number of hydrogen atoms of that compound with the corresponding alkane, right? And whatever delta of H comes, use that to find the degree of unsaturation. Here in our case, delta H comes out to be 0, so degree of unsaturation is 0. Now, option 1, if you look at to the list 2, in the list 2, option 1 says the number of optically active ethers. So first of all, we need to draw the number of ether, right? Now we know ether is what? Ether is ROR. Ether is basically ROR. So we have to draw different type of alkyl groups around the oxygen. Right now we are having 4 carbon atoms, so we can do one thing. We can have a different combinations of 4 carbons around the oxygen atom. First combination is like this, that 3 carbon atoms on the one side and 1 carbon atom on the other side. Second combination can be that 2 carbons on the one side and 2 carbons on the another side. So if we talk about the number of carbon atoms around each oxygen, only these two cases exist. You can do by yourself also. You will find that only 2 cases exist here in the case of ether, where we talk about the number of carbon atoms around each oxygen. So the ratio is what? Here 3 carbons are there, 1 carbon is there. Here 2 carbons are there, 2 carbons are there. One more thing we can do is that in the case of first one, just let me number it. This is compound A and this is molecule B. In the case of A, we can do one change, that on the left side there are 3 carbons chain, which is a straight chain. We can do one thing, that we can make a branch chain of this straight chain like this. So if we do this thing again, it is also an isomer, it is also an ether, but it is a what? It is a chain isomer of the ether, right? So we, that means we have total of 3 ethers possible in this molecule. So number of ethers, if we talk about structural ethers, So there are three structural ethers, right? Total number of structural ethers are three. So if we talk about the option of three in the list three, the option three matches with S. Option three matches with S, right? Like this. Next, if we talk about the total number of primary alcohols, right? In the case of alcohols, which one? Primary alcohols. Now, alcohols, primary alcohols are what? Where we have only 1 degree carbon containing the OH. Or we can say the carbon should be of 1 degree which is having OH, right? So that means we will use one carbon and write the OH along with it. Now there are 3 carbons left in the molecule, so we will do the chain isomers of these 3 carbons. First case, in the primary alcohols, the first molecule will be this one. So all the 4 carbons in the straight chain, and OH is attached to the last carbon being 1 degree. This carbon is 1 degree, right? Because it is having only 1 cc bond. 1 degree carbon is what? 1 degree carbon is that carbon which has only 1 cc bond. Another chain isomerism we can draw. What we can do, we have to play with these 3 carbons. These 3 carbons we have to play in that form of chain to obtain different type of primary alcohols, right? How it will be, let's see. If I draw like this, again this is also a primary alcohol, right? Let's see if we have another option. In the case of 4 carbons, first option is there, A is this, B is this, right? So there are 2 primary alcohols which we can have. If we see about the third option, there will not be any other third structure, right? So the number of primary alcohols which are available to us are 3. 2, sorry. There are 2 primary alcohols, there are 3 structural ethers. So the number of primary alcohols, 2. It is going to option R, like this, right? 2 goes with the option R. Next, the question is saying number of optically active ethers. How many optically active ethers are there? To find the optically active ethers, we need to have the chiral center in the case of ethers. If you look at molecule A, the molecule A doesn't have any chiral center, so it is optically inactive. If you talk about molecule B in ethers, it is also having no chiral center, again it is optically inactive. And if you talk about option C, molecule C in the case of ethers, again if you see, there are 2 CH3 groups on this carbon. On this carbon there are 2 CH3 groups, that means it is also optically inactive. That means there is no ether formed which is optically active. That means option 1 goes to P. Option 1 goes to P, right? And the last fourth option, total number of optically 2 degree alcohols. That means we need to draw the 2 degree alcohols, that is secondary alcohols. And if we have to draw the 2 degree alcohols, what do we need to do? We need to draw the second degree carbon, and second degree carbon is like this carbon is there, and this must have one carbon like this, and we have the OH at the second degree carbon, and this carbon should have another carbon here. That means this is a basic structure of 2 degree carbon, right? This is the basic structure of 2 degree carbon. Now the third carbon which is remaining can come here, it has to come here only, right? So secondary alcohols, how many are there? If you look at the structure, only one kind of secondary alcohol is possible, right? 2 degree alcohol. Or if I try to draw in another way, if I say that this is a straight chain of 4 carbons, because we have only 4 carbons in the molecule, so if I attach OH to the 2 degree carbon, we will get secondary alcohol. And how many 2 degree alcohols are there? Only 2. This is 2 degree and this is 2 degree. That means if I attach OH here, it is 2 degree alcohol, right? but attaching the OH at C1 and C2 will give you the same molecule. And why it is giving us same molecule, I will leave this thing to you only. Just try to understand. Think why attaching the oxygen to the C1 or C2 give you the same type of secondary alcohol. So the secondary alcohol which we obtain here, if you see on this carbon, on the carbon which is marked red, four different groups are attached, right? That means this carbon is what? This carbon is a chiral center. That means it is optically active. So if it is optically active, we will have two type of isomers. Either it will be R or it will be S. That means there are two optical isomers here, right? The optically active carbon can either be R configured or it can be S configured. That means there are two optically active isomers in the case of secondary alcohols. So total number of optically active 2-degree alcohols, how many will be there? The option fourth, it should go to 1, right? The question is saying how many optically active 2-degree alcohols. Optically active 2-degree alcohols are only this one, right? This is the one which is optically active. Yes, it has two isomers, but the question is asking how many alcohols are optically active. So it will be only one, right? In the case of 2-degree alcohols. So if you look at the options, if you try to match the options correctly, we will have first with the P. So the P option goes with the first one, Q option goes with the fourth one, R option goes with the second, and S option goes with the third. So C